Hello. So for our first topic, let me give you a quick overview of the objective of this course, as well as some background before we proceed to the activities that should be primarily review material. So what is our course objective? The objective fundamentally is to learn how to design digital signal processing systems. So design systems to process signals, okay, as well as to be able to analyze the property of those signals. So let's start writing some of these notes. So course objective be able to learn how to design DSP, digital signal processing systems, okay, to process, to analyze all types of signals. Now, what are the main problems? I mean, in this course, we are going to cover a lot of techniques, a ton of transforms, continuous time Fourier transform, discrete time Fourier transform, digital Fourier transform, fast Fourier transform, filters, FIR filters, IIR filters, and it may seem like a lot of disconnected material, but you're going to see that concepts that appear to be disconnected are quite intertwined. And perhaps a good framework to have as you're studying all these techniques that seem to be disconnected is to think about what are the main problems that we are trying to solve, right? What are the main problems that we are addressing in digital signal processing? And so, if you think about DSP, any course in digital signal processing, we are trying to solve two type of problems, fundamentally. We're trying to solve a problem of analysis, is giving a signal or giving a system how to analyze it to understand its properties. And fundamentally, one of the most important ways we are going to see that is spectral analysis. Right? So, given a signal, what is the spectrum of the signal? What is the frequency content? Giving a system, what is the frequency response? How does it behave as a function of frequency? So I'm going to mention this as frequency content analysis. So the first main problem is giving a signal, giving a system. Let's look at it not in the time domain, but in the frequency domain. What is the frequency content of the signal? How does the system react to signals of different frequencies? And once we analyze those signals and those systems, or once we analyze those signals, is how do we create systems with the right characteristics to transform those signals in the way we want? So, this is the problem of processing, which in this course primarily is going to be done through filtering. How do we filter? The problem of filtering, right? How do we transform those signals to have the characteristics we want? So first, you have a signal, let's analyze it, let's understand it, and a good way to do that is a starting point is going to be, let's do a spectral analysis. Let's look at the world in the frequency domain. And then once we know the frequency content, and we know perhaps what are the areas of the signal that we want, and the ones that we want to remove the noise, or how do we want to transform the signal to fit our particular application, we need to be able to design those filters that will enable us to solve that problem. So aside for the problem and learning how to do analog to digital conversion and digital to analog conversion and aliasing, so that we can do this in digital, all the techniques that we are going to be learning in the course either are solving the problem of spectral analysis. So when you're thinking about the continuous time Fourier transform, the discrete time Fourier transform, the digital Fourier transform, the fast Fourier transform, time frequency spectral analysis, spectrograms that we're going to see, all of those are solving the first problem, the problem of analysis, and concretely the problem of spectral analysis. Similarly, when we are looking at finite impulse response filters, infinite impulse response filters, how they behave, etc., we are solving the problem of filtering. So just keep this in mind when we are studying a topic: is what is this topic for? Is it helping us with analyzing, being able to understand better signals, as well as systems, or is it creating systems?